Hello friends, welcome back. So in this video we will see the definition of probability distribution function, and we will also see the definition of the density function. So first, probability distribution of a random variable describes how the probabilities are distributed over a given possible values of that variable. So that is meant by probability distribution, how the random variable is taking different probabilities and how they are distributed. Now if we how we define the distribution function means distribution function distribution function is denoted by capital suffix capital X. X is the random variable and this is the random variable random variable, and small x is the value taken by the random variable. So how we will define the distribution function means, so if p of capital X less than or equal to small x, so what it denotes is the probability is the probability probability of the event probability of the event capital X less than or equal to small x. So the random variable is taking all the values up to small x, so it is denoted by probability of capital X less than or equal to small x. So this is called as the distribution function. Fx of x is nothing but probability of x taking all the values less than or equal to small x. So this is the definition of the distribution function, or this is also called as cumulative distribution function. This is also called as cumulative distribution function because it is adding all the probabilities of the random variable x is taking up to the value small x. Cumulative distribution function, or in short it is denoted with CDF, cumulative distribution function, or we in short we can call simply the distribution function. So this is the definition of the distribution function. Next, density function density density function density function density function is denoted with small f suffix capital X of x. So distribution function is denoted with capital letter. Distribution function is denoted with capital letter, whereas density function is denoted with small letter. So density function fx of x is given by d by dx of distribution function fx of x. So this is how we define the density function. Density function is nothing but differentiation of the distribution function, or it is also called probability density density function. So in short, or it is denoted with PDF probability density function, whereas distribution function is called CDF. So there are few important properties for distribution function. Fx of minus infinity is always 0, and fx of infinity is always 1. So therefore the range of values the distribution function can take is always lies between 0 to 1. So this is very important property that is useful while solving the problem. And always the second important property is probability of x1 less than capital X less than or equal to x2 is given by, that means probability of the random variable x taking values between x1 and including x2 is given by fx of x2 minus fx of x1. This property is also very useful while solving many problems. And similarly there are one important property of the density function that we will use most of the times while solving the problems is the area under the density curve. Area under the density curve is 1. So that means integral minus infinity to infinity fx of x dx will be 1. So this property will be very useful while solving the problems related to density function. The another important property is if we want to find the probability similar to here by using distribution function. Similarly if you want to find probability of x, the random variable taking values between two values x1 to x2, if we are given the density function, we can find by integrating x1 to x2 the density function. So this is another property that is very useful. And sometimes we will be given the density function, we will be asked to find the distribution function. So as we have defined, the density function is nothing but derivative of the distribution function. So we can find the distribution function by sending this dx the other side, and 1 by d will be integral. So fx of x is integral minus infinity to x fx of zeta. We are using some other variable because it is a function of x, and d zeta. So this is also very useful property or useful thing if we are given the density function, how to find the distribution function. So these are the properties and the definition of the distribution function and density function. So distribution function means the range of values the random variable x takes up to a certain value small x is nothing but the distribution function. So it is called CDF, whereas the density function is nothing but the derivative of the distribution with respect to that variable it is taking is called the density function. So I hope you are able to understand what is distribution function and what is the density function, and these are the properties. These are very useful for solving the problems related to distribution function and density function. Please remember these formulas. These formulas are properties, they are very useful. So thank you for watching. If you didn't subscribe to my channel, please subscribe, like this video and share with your friends. Thank you.